Today's lesson is 5-5, and we're going to solve problems using the distance and midpoint formulas. Today our objectives are to develop the midpoint and distance formulas, find the midpoint of a line given 2 points, and find the distance of a line given 2 points. Now this very first objective right here, to develop the midpoint and distance formulas, we're actually going to do that objective in class tomorrow. Today we're going to be focusing in on these, or on the video we're going to be focusing in on these second two, to find the midpoint and find the distance. Here's the distance formula. I want you to go ahead and write down what's in the red box. So our distance formula is d equals the square root of x2 minus x1 squared plus y2 minus y1 squared. So go ahead and write down what's in the red box. And down here at the bottom it says the distance formula can be derived from the Pythagorean theorem, which most of you know about the Pythagorean theorem being a squared plus b squared equals c squared. And we're going to look tomorrow in class about how those two things are connected. If you need to pause the video to finish writing down the distance formula, feel free to do that. Oops, there you go. Alright, now here's the midpoint formula. I want you to go ahead and write down what's in the red box here as well, because we're going to be using both of these formulas today. This one's the midpoint. And the midpoint formula is actually a point. It's the middle point between two other points. And it's x1 plus x2 divided by 2 and y1 plus y2 divided by 2. So you can write down what's in the red box. It says the midpoint formula gives the midpoint of a line on a coordinate plane. You don't have to write that part, just what's in the red box. If you need more time, feel free to pause the video. All right, here's our first one, and give me just a second. We are going to do this one on paper. All right, here's number 1. Go ahead and write down those 2 points, -8, 6, and 4, -3. And our directions say, find the coordinates of the midpoint of the segment with these 2 endpoints. So here we're asked to find the midpoint, so I'm going to write the midpoint formula down again. Alright, so there's my midpoint formula, and I'm going to go through just like I did with the slope formula, and I'm going to label these points x1, y1, x2, y2 to make sure I get them all put in the correct place. So then I'm going to plug those numbers into my formula. So x1 plus x2 is -8 plus 4 over 2. And y1 plus y2 is 6 plus -3 over 2. And then I'm going to simplify this just a little bit by adding the top numbers. So I'm going to say -8 plus 4 is -4 over 2. And 6 plus -3 is 3 over 2. And then I'm going to divide, and that's going to give me my final answer. -4 divided by 2 is -2, and 3 divided by 2 is 1.5. So there's my midpoint. So if I were to graph these 2 points right here on a coordinate plane, then this point right here would be exactly in between those 2 points. It would be in the middle of those, which is why it's called the midpoint. Make sure you have all that down before you move on. Alright, this is the same problem we just got finished working. I just wanted to show you the illustration here. I have the point -8, 6 and the point 4, -3. And if I plot that midpoint, it's right there in the middle of those two. Oops. So I just wanted to show you how that actually is the midpoint of those 2 points. All right, our next one says, on the map of Mathville, Town Hall is at the origin 0, 0. Allen lives 3 blocks east and 2 blocks north of Town Hall, and Bart lives 11 blocks east and 8 blocks north of Town Hall. You do not have to write that down. I'm going to show you our map of Mathville here. Okay. And then we're going to put this on a coordinate plane. So here we go. We've got Alan's house is right here, and here's Bart's house. It says, Alan and Bart plan to meet exactly halfway between their houses. What are the coordinates of the location where they should meet? So if it's halfway between their houses, that's asking for the midpoint. And here, the way I get my points here is if Alan lives 3 blocks east and 2 blocks north, his point is 3, 2. Because this one's east and up and down is north and south. So, and then we have Bart. Bart's house is at 11, 8 because he lives 11 blocks east and 8 blocks north of Town Hall. All right here's where you need to start writing down. You need to write number 2 and the point 3, 2 and 11, 8. And you need to go ahead and label those x1, y1, x2, y2. And go ahead and write down that midpoint formula again. And again, I know I'm looking for the midpoint because they want to know where would halfway be if they were going to go and meet halfway. So after I have my points labeled, I'm going to plug them into my formula, and I should get 3 plus 11 over 2 and 2 plus 8 over 2. I'm going to add the top part and say that 11 plus 3 is 14 over 2 and 2 plus 8 is 10 over 2. And then I'm going to divide, and I get 7 and 5. So you can see whenever I do put this on a coordinate plane, then if this is 3, 2 and that's 11, 8, right here they're going to meet at the park. The park is exactly halfway between their 2 houses. All right, make sure you have everything over here written down before you move on. All right, so there's our second objectives. Again, we're going to leave that first one for tomorrow in class. So now we can find the midpoint of a line given 2 points. And now we're going to look at that distance formula. All right, here's problem number 3, and we're going to find the distance of these 2 points using the distance formula. So go ahead and write that down. We've got the point 3, negative 2, and the point 5 and negative 6.5. Again, first thing I'm going to do here is label these x1, y1, x2, y2. And I'm going to use the distance formula because that's what it's asking me to do. It's asking me to find the distance. So I'm going to rewrite down the distance formula. x2 minus x1 squared plus y2 minus y1 squared. There's the distance formula. It's a little bit more complicated than the midpoint formula, but we're going to take it step by step. So I'm going to do my square root, and I'm going to start plugging my points in. So it's going to be 5 minus 3 squared plus negative 6.5 minus a negative 2 squared. So make sure you've plugged in your points correctly. Here, the first thing I notice here is that I have these 2 negatives right here, this minus a negative, and that's going to turn into a positive. So I'm going to turn that into a positive right there. Okay, now from here it's just order of operations, and order of operations says we need to do what's inside the parentheses first. So I'm going to say 5 minus 3 is 2, so 2 squared, plus negative 6.5 plus 2 is negative 4.5 squared. Then my order of operations says to do my exponents. So I'm going to say 2 squared is 4 plus negative 4.5 squared is 20.25. And then I'm going to add those. I'm doing everything underneath the radical before I actually take the square root. So 4 plus 20.25 is 24.25. And then I'm going to find the square root button in my calculator because this is definitely not a perfect square. So I'm going to say square root of 24.25 And I'm going to find out that that's approximately, so I'm going to change that equal sign to an approximately symbol, meaning I had to round that. So it's approximately and not exactly 4.92. So my distance between those points is approximately 4.92. We're going to round to the nearest hundredth here. Make sure you have that down before you move on. All right, here's number 4. I'm not going to ask that you draw that picture or anything. You're just going to do the work over to the right. It says, what is the length of MN? So we have M and N, and we need to pick these points off of our graph. It says finding the distance between 2 points is the same as finding the length. So length and distance are the same thing. So we're going to identify those coordinates. This one is 2, 5. Again, I pick up the X first, and I had to go right 2 spaces, so that's a 2, and then I had to go up 5 to get to that point, so that's the point 2, 5. This one's 4, -1, meaning that from the origin I had to go to the right 4, so that's where the positive 4 came from, and then I had to go down 1, so that's where the -1 came from. So I'm going to identify those coordinates, and this is where you're going to start writing down. You're going to write number 4, and you're going to write these 2 points down, 2, 5, and 4, -1. You're going to go ahead and label those points, x1, y1, x2, y2. And you're going to go ahead and write down your distance formula again. Okay, now we're going to plug in our numbers. So our x2 is 4 minus our x1, which was 2, squared. And again, I got those from up here, 4 minus 2. Squared plus -1 minus 5 squared. Again, I'm going to do what's inside the parentheses first. So I'm going to say 4 minus 2 and -1 minus 5. And I get the square root of 2 squared plus -6 squared. Then I'm going to square each one. So I'm going to do the exponents. I'm going to say 2 squared is 4 and -6 squared is 36. Now be careful. This is the biggest mistake that people make. -6 squared is -6 times -6, which is a positive 36. 36 plus 4 is 40, so the square root of 40. So then, again, we're going to use our calculator, and we're going to say the square root of 40, and we're going to round to the hundredth, and we're going to say that that's approximately, again, our little squiggly equal sign, meaning approximately 6.32. So make sure you have everything on the right written down before you move on. You don't have to have these words in blue here. All right, here's number 5. We're going back to Mathville. It says, Bart plans to ride his bike to Alan's house. How far will he ride? So he's wanting to go up here from Bart's house, and he wants to end up at Alan's house. So we're looking for the distance between those 2 houses to know how far he's going to have to go. So we're going to be using the distance formula this time. Again, identifying the coordinates, and we talked about that earlier, 3, 2, and 11, 8 were our coordinates for this one. So go ahead and write down those coordinates. So again, you should write number 5, and then write these 2 points down, and then label them, and write down your distance formula. You don't have to write this part right here. All right, if you need to pause the video to get the rest of that down, that's fine. We're going to go ahead and plug our numbers in here. So we're going to say x2 is 11 minus x1, which is 3, squared, plus y2, which is 8, minus y1, which is 2, squared. Then we're going to do what's inside the parentheses. So we're going to say 11 minus 3 is 8, so 8 squared, plus 8 minus 2 is 6, so 6 squared. So then I'm going to square both of those numbers. 8 squared is 64, and 6 squared is 36, so 64 plus 36. Then I'm going to add those numbers together, and I get the square root of 100. Now this one works out nicely because the fact that the square root of 100 is exactly 10, so we won't need those approximately this time. But we will, however, need the word blocks here, because anytime you're given a real-world problem and it's giving you units of some sort, you need to make sure and put those units. So here it is 10 blocks from Bart's house to Alan's house. So if Bart plans to ride his bike to Alan's house, he will have to ride 10 blocks. Make sure you have all that written before you move on. All right, number 6 is kind of an extension of question number 5. It says, Bart is halfway to Alan's house when the chain came off his bike. He could not fix it and had to wait for his dad to come and pick him up. How far did he ride his bike? So he's wanting to know, he rode his bike halfway. We're trying to figure out how far is halfway. Now, they're not asking for the midpoint here. They're not asking for what is the middle point. They're saying how far is it from Bart's house to this middle point right here. Well, we know that with the midpoint, it's the same distance from Bart's house to the playground, which is halfway, and then it's the same distance from the playground to Alan's house. So we're going to take the distance and cut it in half, because that's what a midpoint is. It's cutting the distance in half. So if he rode 10 blocks to get the entire way, he only rode 5 blocks to get halfway. So for number 6, you need to write he rode 5 blocks and then half of the 10 blocks whenever his chain came off his bike. All right, number 7 says each unit on this map of a public park represents 1 kilometer. To the nearest tenth of a kilometer, what is the distance from the campground to the horse stables? So here's my campground, and here's my horse stables. So I need to know how far is it from the campgrounds to get to the horse stables. So they're asking me for the distance. So I'm going to use the distance formula, but I have to pick out my points first. So we're going to identify the coordinates. The campground is 1 for your X and 3 for your Y, so 1, 3. The horse stable is right in the middle of the 4 and the 5, so we're going to call that 4.5, and it's on the 1 on the Y-axis, so that's going to be 4.5 and 1. So there are my coordinates. Go ahead, you should have number 7 written, you should have these 2 points, you should have them labeled, and you should have the distance formula written down. Okay, if you need more time to get that written down, you'll need to pause your video. We're going to go ahead and plug stuff in. We're going to say 4.5 minus 1 right here, squared plus 1 minus 3 squared right here. Again, I'm going to do what's in parentheses first. So I'm going to say 4.5 minus 1 is 3.5, and 1 minus 3 is negative 2. So the square root of 3.5 squared plus negative 2 squared. Then I'm going to square both numbers, and I'm going to say that 3.5 squared is 12.25, and negative 2 squared is a positive 4, because that's negative 2 times negative 2. Then I'm going to add those numbers together, and I get the square root of 16.25. So then again, I'm going to use my calculator and my square root button, and we're going to say the square root is 16.25, and that's going to be 4.0 kilometers, and this should actually be one of those squiggly equal sign, because we did actually have to round to the 10th. And again, you need to have the km right here for kilometers, because again, it's a real world problem, and they gave you units to go by, so you need to make sure you have those units in your answer. That way I know that it's 4 kilometers, and I don't think that it's 4 miles or 4 inches or something like that. I know that it's 4 kilometers. Make sure you have all that written before you move on. A square, number 8 says a square is plotted on a coordinate grid. The endpoints of one side of the square are negative 2, 2, and 3, 3. Each unit represents 1 centimeter. What is the perimeter of the square? This one's probably the hardest problem that we're going to look at, but the EOC at the end of Algebra 1 loves to put questions like this on there because of the fact that it tests multiple things at once. You have to know what a square is, you have to know what perimeter means, and you have to know how to find distance of 2 points. So anytime I don't necessarily know where to start, I go ahead and draw me a little picture. Okay. I make sure and draw the little picture because it says a square is plotted on a coordinate grid, and they gave me 2 points. They gave me -2, 2 right here, and they gave me 3, 3 right here. So I'm going to draw myself a picture. And I know that if it's a square that all the lengths of each side are the same. So if I find the length from here to here, then I also know the length of this side, the length of this side, and the length of this side. So first thing we're going to do is find the length right here, which is also the same thing as the distance. So I have my points, and again I'm going to label them x1, y1, x2, y2. So you need to write number 8, and you need to have these 2 points written down and labeled in your distance formula. So if you need to pause the video to do that, feel free to do that. So I'm going to plug my numbers in. I have the square root of 3 minus -2 squared plus 3 minus 2 squared. Again, these 2 negatives right here are going to turn into a positive. So I'm going to do what's inside parentheses first. And I get the square root of 5 squared plus 1 squared. Then I'm going to square both of those numbers. 5 squared is 25 and 1 squared is 1. Then order of operations tells me to add. So I'm going to say the square root of 26. And again, then I'm going to use my calculator. And we're going to say that that's approximately 5.1. Now, I'm not finished with the question that they asked me. They didn't ask me just to find the distance from -2, 2 to 3, 3. They asked me to find the perimeter of the square. So all I've found right now is my distance from here to here. But I know if this one is 5.1, then this one is 5.1, the one down here is 5.1, and so is this one over here. And perimeter means that I take all the sides and I add them together. It says find the perimeter by adding together the length of all the sides. So I can either say 5.1 plus 5.1 plus 5.1 plus 5.1, or I can just multiply it by 4. So the perimeter of a square is 4 times the length of the side. So 4 times 5.1 is approximately 20.4 centimeters. So make sure that you answer the question that they're asking here. They did not just ask for the distance, they asked for the perimeter of the square. So we had an extra step there. We had to take and either add 5.1 4 times or multiply 5.1 times 4. And again, please make sure that you have the centimeters, because it's always important that if they give you units, that you write those units down. Okay, make sure you have all that down before you move on. Alright, so there's our second objective as well, and it's going to say that we have covered the first one. We haven't, but we will in class tomorrow. So we can now find the distance given 2 points and the midpoint given 2 points. And again, tomorrow we're going to talk about how those midpoint and distance formulas were developed. Alright, so that is the end of your video. Thank you for watching.